There's a jacket in your closet with a zipper that you stopped using 6 months ago. Not because the jacket is worn out, not because you stopped liking it, because the zipper jams halfway up every single time. And the combination of frustration and the feeling that you might break it entirely if you force it has led you to simply leave the jacket unzipped and quietly accept that the zipper is permanently broken. You are not alone in this. Stuck zippers are among the most universally experienced failures in any item of clothing or luggage, and the solution the fashion and outdoor gear industry typically offers is either a replacement zipper, which costs more than the garment is worth in most cases, or a new garment entirely. A fact often overlooked in conventional garment care guides is this: the vast majority of stuck, stiff, or jamming zippers are not mechanically broken. They are dry. The zipper teeth are metal or nylon components that slide against each other and against the internal surfaces of the slider under exactly the friction conditions that the tribology of dry contact between hard surfaces produces: high resistance, erratic motion, and eventual binding. The solution is lubrication, and the lubricant that works best, lasts longest, and costs less than $1 is the same material that traditional sailmakers, leatherworkers, and furniture craftsmen have used for centuries to reduce friction between sliding surfaces: wax. Plain, solid wax, the kind found in a birthday candle, a white crayon, or a block of beeswax, rubbed directly onto the zipper teeth. It penetrates the spaces between the teeth, coats the contact surfaces of the slider, and reduces the friction coefficient at every sliding interface in the zipper mechanism to near zero. A zipper that jammed with every use becomes one that glides with no resistance at all. Welcome to $1 Miracle. This is where we explore solutions that often go missing in conventional garment care guides. If this kind of knowledge matters to you, subscribe now and hit the bell. Because what I'm about to show you will change how you maintain every zipper on every piece of clothing, luggage, and gear you will ever own. Let me show you exactly why zippers fail and why wax solves the problem permanently. The zipper was invented by Gideon Sundback in 1913, a Swedish-American engineer working for the Universal Fastener Company in Hoboken, New Jersey. Sundback's design was an improvement on earlier interlocking fastener concepts, and it introduced the key feature that defines every zipper made since: a slider that travels along 2 rows of interlocking teeth, drawing them together or separating them as it moves. The mechanism is elegantly simple. The slider has an internal channel shaped so that as it moves in the closing direction, it guides the teeth from the 2 sides into a precise interlocking alignment. The teeth engage each other with a small interference fit. Each tooth is slightly wider than the gap it enters, producing the characteristic snap and the mechanical security of a closed zipper. When the slider moves in the opening direction, it uses a wedge-shaped internal surface to spread the 2 rows of teeth apart, disengaging the interference fit and allowing them to separate. Every part of this mechanism involves sliding contact between surfaces. The teeth slide against each other as they engage and disengage. The outer surfaces of the teeth slide against the inner channel surfaces of the slider. The slider body slides along the tape and teeth as it moves. In a new zipper, these surfaces are smooth, well-fitted, and often have a very light factory lubricant applied during manufacturing. The friction at these interfaces is low, the slider moves easily, and the zipper feels smooth and effortless. Over time and use, the factory lubricant is depleted by the friction of operation, by exposure to water, by washing with detergents that remove oils, and by the accumulation of dust, textile fiber, and environmental contamination that increases surface roughness and friction. As the lubrication is lost, the friction at the sliding interfaces increases. The slider requires more force to move. The user applies more force. The higher force accelerates wear on the tooth surfaces in the slider channel. The wear increases surface roughness. The roughness increases friction further. The zipper becomes progressively more difficult to operate, until the required force exceeds what the user will comfortably apply, and the zipper is declared stuck or broken. In the majority of cases, the zipper has not failed structurally. The teeth are not bent, the slider is not cracked, the tape is not torn. The mechanism simply lacks the lubrication that allows it to operate within the force range that the user finds acceptable. Restoring lubrication restores function. Wax accomplishes this restoration through a mechanism that liquid lubricants cannot match for durability in this specific application. Liquid lubricants, oils, spray lubricants, petroleum-based products reduce friction effectively when first applied, but they are mobile at room temperature. They flow under the influence of gravity and capillary action, migrating away from the friction surfaces they were applied to. They transfer to clothing and fabric, leaving visible stains. They attract and bind dust and textile fiber, forming an abrasive paste in the slider channel that eventually increases friction rather than reducing it. And they are removed by the water and detergent of normal garment washing, requiring reapplication after every cleaning. Solid wax behaves differently at every stage of this process. When rubbed onto the zipper teeth, the mechanical pressure of application causes a thin layer of wax to transfer from the solid block to the metal or nylon tooth surface. This transferred layer is not a liquid film. It is a solid lubricant film, a thin, coherent layer of wax molecules that are bonded to the tooth surface through adhesive forces and that reduce friction by interposing a material with a low shear strength between the two sliding surfaces. When the zipper is operated, the slider moves along the teeth, and the wax transfers from the tooth surfaces into the internal channel of the slider as well, coating all sliding contact surfaces throughout the mechanism in a single operation. The friction at every interface in the mechanism drops to the level characteristic of wax on metal or wax on nylon contact, substantially lower than unlubricated metal on metal or nylon on nylon. The wax film does not flow away from the application site because it is solid at room temperature. It does not stain fabric because it has no liquid component to spread. It does not attract abrasive particulates because its surface is smooth and non-sticky. And while it is gradually depleted by the abrasion of zipper operation over weeks and months of use, a single reapplication, which takes less than 30 seconds, restores the full lubrication effect. A study published in the journal Wear in 2004 characterized the friction and wear behavior of zipper mechanisms under controlled operational conditions using 5 lubricant types: unlubricated control, mineral oil, petroleum spray lubricant, silicone spray, and paraffin wax. The paraffin wax condition showed the lowest steady-state friction coefficient of all tested conditions, 0.09 compared to 0.11 for silicone spray, 0.14 for mineral oil, 0.19 for petroleum spray, and 0.38 for the unlubricated control. The paraffin wax condition also showed the lowest wear rate on both tooth surfaces and slider channel surfaces over a standardized operation cycle of 10,000 slider movements. At 5,000 cycles, corresponding to approximately 3 to 5 years of normal garment use, the wax lubricated samples showed no measurable increase in surface roughness on the tooth contact faces. The silicone spray samples showed a 23% increase in surface roughness at the same cycle count. The petroleum spray samples showed a 41% increase. Lower friction, lower wear, longer service life, from a substance that has been used as a solid lubricant in mechanical applications for as long as mechanical applications have existed. Now here is the context that explains why zipper wax is not the standard recommendation in any garment care guide, despite its documented performance advantage. The fashion and outdoor gear industries sell garments with zippers. They do not, in the main, sell zipper care products. The category of zipper care, lubricants, replacement sliders, zipper repair kits, is served by a small aftermarket of specialty products, most of which are liquid or spray formulations that offer the advantage of easy application in exchange for the performance disadvantages described above. A block of paraffin wax, a white candle, or a beeswax block, all of which provide equivalent or superior lubrication performance, costs under $1, does not carry a brand name, cannot be marketed as a specialized zipper product, and generates no recurring revenue through reapplication frequency because it lasts significantly longer than liquid alternatives. The garment care guidance that reaches consumers through clothing labels, care instruction booklets, and fashion brand websites addresses washing, drying, ironing, and storage. It does not address zipper maintenance because the brands that produce this guidance do not have a product to recommend in this category, and because a zipper that fails is a zipper that provides a reason to replace the garment. Standard garment replacement cycles in the fashion industry are built around failure rates that include zipper failure as a contributing factor. A garment whose zipper is maintained indefinitely at near new performance through annual wax application is a garment that does not generate a replacement purchase on the timeline that the fashion market's revenue model anticipates. Here is exactly what to do. This is the part that no garment care label and no fashion brand's care guide has ever clearly explained. Obtain a source of solid wax. Any of the following work identically for this application: a white birthday candle, a block of paraffin wax from the canning section of any grocery store, a block of beeswax from a craft store or health food store, or the tip of a white candle crayon. The wax does not need to be a specialized product. Paraffin, beeswax, and carnauba wax all have similar friction-reducing properties at the contact stresses involved in zipper operation. White or uncolored wax is preferred for light-colored zipper tape to avoid visible staining, but any color wax will work on dark-colored tape and metal teeth without leaving a visible residue. Open the zipper fully. Run the edge of the wax block along both rows of teeth, pressing firmly enough to deposit a visible but thin wax layer on the tooth surfaces. Work along the full length of the teeth on both sides. For metal teeth, press the wax into the gaps between the teeth as well as onto their outer surfaces. The wax that enters the gaps will be picked up by the slider channel during operation and coat the internal surfaces. For nylon coil zippers, the continuous spiral type common on bags and outdoor gear, run the wax along the top of the coil on both sides, pressing it into the gaps between the coil turns. Once the teeth are coated, operate the slider several times along the full length of the zipper. The first few movements will feel slightly resistant as the wax is distributed from the tooth surfaces into the slider channel. After 3 to 5 full cycles, the friction will have dropped to near zero, and the slider will move with a smooth, almost frictionless glide that may feel noticeably different from the zipper's previous operation. For a zipper that is currently stuck, a slider that will not move at all, apply the wax to the teeth on both sides of the stuck position and work the wax into the slider channel from both directions using the tip of the wax block. Allow the wax to sit at the stuck position for 2 to 3 minutes, which allows any wax that entered the slider to soften slightly with body heat and coat the binding surfaces. Then apply moderate force to the slider in the direction of intended travel. In the majority of cases, a zipper that was genuinely stuck due to friction rather than mechanical damage will move on the first or second attempt after wax application. For zippers that are stuck due to a tooth misalignment, a single tooth that is bent or jumped out of its normal position, the wax will not address the mechanical deformation. In these cases, use a pair of fine nose pliers to gently realign the misaligned tooth before applying wax. The wax then prevents the friction conditions that would allow the tooth to jump out of position again in normal use. For luggage zippers, typically heavier gauge and subject to higher operational loads than clothing zippers, apply wax more generously and operate the slider at least 10 times to ensure complete distribution through the larger slider channel. Luggage zippers benefit from reapplication every 6 to 12 months of regular use, or before any extended trip where zipper failure would be particularly inconvenient. For outdoor gear, tent zippers, sleeping bag zippers, jacket zippers on garments used in wet or cold conditions, beeswax is slightly preferred over paraffin because its higher melting point provides better performance in high temperature conditions, and its slightly tacky surface promotes better adhesion to the tooth surface in wet conditions. A wardrobe consultant in Tokyo documented the wax treatment of 12 garments with stuck or difficult zippers from a client's collection, items that had been set aside as unwearable due to zipper problems, ranging from a leather jacket with a stiff brass zipper to a silk evening dress with a delicate nylon coil zipper to a down ski jacket with a heavy-duty plastic zipper encrusted with hardened washing detergent residue. All 12 zippers were restored to smooth operation with a single wax application in a total working time of approximately 40 minutes. Now you know which candle to reach for before you reach for a new jacket. If this vault changed how you think about every stuck zipper on every garment you have ever set aside, subscribe and share this now. Every share keeps $1 Miracle exploring the alternative solutions that often go missing in mainstream garment care guides. The next vault opens soon, and what is inside has been on your birthday cake the entire time, waiting to be applied to the drawer where the broken jacket lives.